Hello, good morning everyone. I can't believe we are already at day 5 of the winter school. I hope you're all enjoying Qatar and the school. So it's my pleasure to introduce Avishkar. Avishkar is a staff research engineer at Google DeepMind. He currently works on AI for education, a team with a mission to build an AI tutor for every learner. His research interests include RL and multi-agent methods. Avishkar is also a long-standing organizer and executive board member of the Deep Learning Indaba. Please give him a big applause.
Hey everyone, can you hear me? Cool. Yeah, really great to be here, and very nice to also see some familiar faces from the Indaba community around. So in today's talk, I'm going to tell you a bit about AI for education. So I'll start with an introduction and then go through the scale and complexity of the problem. I'll talk about evaluation, some of the research challenges in the space, and then end with some ethics and safety considerations. Okay, so let me tell you a story about Amira. Amira is sitting in her calculus class, staring at derivatives on the board. She knows she's missing something fundamental, but can't quite put her finger on it. Amira's teacher is excellent, but with 27 other children in the class, they're moving at the pace of the class average. Amira glances at the clock. There's only 20 minutes left. She should raise her hand, but the thought of doing this makes her stomach tighten. 3 other students have already asked questions, and besides, her confusion feels too basic. Maybe she should have figured this out weeks ago. Amira isn't alone. Maybe you've had a similar experience in school. After class, private tutoring.
Closer to the microphone.
Okay. After class, private tutoring would cost $50 to $100 per hour. This is far beyond what her family can afford. Okay, I'll hold it. Hopefully you can hear better now.
Does it work?
So, yeah, I think it's working. Okay, so she goes home, falls further behind, and the gap widens. But at least Amira was in school. The problem is actually a lot worse than this. In fact, over 250 million children between the ages of 6 and 17 were out of school globally in 2017. And this was exacerbated by the COVID pandemic. More than 600 million students are not achieving minimum proficiency levels in reading and mathematics. 600 million, that's a lot of children. And in addition to the inequitable geographical distribution that you see on these pictures, there's also inequality along gender lines, with large parts of Africa, for example, having significantly lower school life expectancy for girls compared to boys. And the picture is even worse for tertiary education, with extremely low enrollment rates in much of the developing world. So this educational crisis is so critical that the United Nations made quality education their 4th Sustainable Development Goal. This goal aims to ensure inclusive and equitable education and promote lifelong learning opportunities for all. But now here's where it gets interesting. In 1984, an educational psychologist named Benjamin Bloom made a fascinating discovery. Students who received personalized one-to-one tutoring performed 2 standard deviations better than their peers who only received traditional classroom instruction. Now that's a difference between a C student and an A student. The implications of this were staggering. If we could provide this level of personalized tuition to every student, we could dramatically reduce educational inequality, we could improve the quality of education, and make major progress towards achieving SDG 4. But the problem? Scaling one-to-one tutoring to every student would require more tutors than we could ever possibly train. Bloom had discovered education's fundamental paradox. The most effective teaching method is also the least scalable one, and therefore impossible to implement widely. Or is it? This is where generative AI enters the picture. So the current revolution in Gen AI provides AI systems that are more accessible than ever because they only require prompting through natural language. They're more capable than ever, and they appear to be improving faster than ever. And students are early adopters and heavy users of this technology already. A recent survey of university students found that 86% of students use generative AI in their studies. And 54% use it weekly, and 24% use it daily. And I can only imagine these numbers have increased since the time the survey was conducted. So, okay, that's great. Well, does that mean the problem is solved? We already have ChatGPT and students are already using it. So, good job, right? But most modern LLMs have actually been designed with the use case of being a helpful assistant. They're very good at conveying information, giving comprehensive answers to the questions you ask them. And even ignoring the usual problems that we know plague LLMs, like hallucinations and lack of reasoning ability, it's very easy for students to fall into the trap of using these tools to provide direct answers to their homework problems, rather than engaging in the problems themselves. And in a study by Lehman, they found cases where students became over-reliant on LLMs. And they started outsourcing their thinking process to these LLMs. And more concerningly, they found that the self-perceived benefits of using LLMs actually far exceeded the actual benefits. So LLMs in their current form, as helpful assistants, tend to create a false sense of mastery, which I'd argue is actively harmful to learning. So let's talk about why education is such a challenging problem for AI to solve. So when we're talking about education for all, which remember is a key part of that SDG, we're talking about 1.5 billion students worldwide, each who have different prior knowledge, different learning speeds, native languages, cultural contexts, different learning preferences, different access to technology, and different support systems at home. If we're building a tool, like a general purpose AI tutor, for example, then it's not just Amira in her maths class that we need to think about. We also need to think about the elementary student learning to read, the high school student tackling physics, the adult learning a new language, and the vocational student mastering a trade. It's possible to build specific tools for each of these use cases, but one of the lessons that we've learned in AI recently is that we can get a lot of cross-domain transfer by training one big general-purpose model rather than lots of small specific models. And in fact, we'll see shortly that the principles of pedagogy are actually quite general and can be applied in many contexts. So let's look at why a use case like tutoring is such a highly complex task. What makes a good tutor so effective? So maybe think back to a time when you've had a good tutor help you in your studies. Maybe you noticed some of the techniques that the tutor used to make the experience beneficial for you. Perhaps they offered you immediate feedback to encourage you when you were on the right track, and also to quickly catch and resolve any misconceptions before they became deeply rooted. Perhaps it was difficult to notice, but the tutor would have maintained in their mind a working model of your knowledge state, what you know, what you don't know, and what you may believe that might not be true. A good tutor would have adapted and adjusted their explanations to suit your background, your age, and the profile that they had developed about you over multiple interactions. A good tutor would have made you feel safe to ask questions, to get things wrong, to be vulnerable. And they do this by building up rapport and trust. A tutor would have read signals from you, like your body language, your facial expressions, your level of interaction, and used this to infer your emotional and cognitive state. They would have adjusted their responses accordingly. A good tutor, just like a good sports coach, knows when to push you and they know when to back off. Now, unfortunately, there is some disagreement and debate in the teaching and learning sciences community about what exactly constitutes good pedagogy. By the way, pedagogy just means the method and practice of teaching. And you may have seen this yourself, where different teachers have different styles of teaching. And there's not necessarily one style that's better than another. It really depends on the learner and on the context. But as part of my work in my team at Google DeepMind, we did a survey of the literature. We spoke to many teachers, learning science experts, and we tried to distill their knowledge into 5 general principles of pedagogy that can be applied to the design of materials and also to the act of teaching and tutoring. So these principles are: encourage active learning, and active learning means that the learner should manipulate information through discussion, practice, and creation, and not just passively absorb information. Managing cognitive load. Information should be presented in multiple modalities, be well structured, and segmented into manageable chunks. Deepening metacognition. Metacognition is just a fancy word to say thinking about thinking. So learners should be able to reflect on the thought process that they followed in solving a problem. And this enables them to generalize their skills to new contexts. Motivating and stimulating curiosity, which leads to self-efficacy and lifelong learning, and adapting to the learner's goals and needs by assessing their current state, their goals, and making a plan to bridge any gaps. So, in addition to adhering to these 5 pedagogical principles, an AI tutor also needs to model the full space of human knowledge, to understand how knowledge builds upon itself, to adapt to individual learning trajectories, maintain engagement over months and years, and do all of this while being robust, fair, and explainable. Sounds easy, right? But despite the complexity of this problem, you've no doubt seen in many big tech demos the idea that, even if not explicitly stated, that generative AI models are set to disrupt education. And even people very close to the problem, people like Sal Khan, the founder of Khan Academy, actually has a book on this topic and how AI is going to revolutionize education. But haven't we heard this all before? I certainly remember, I was already out of university actually, so maybe I'm giving away my age, when MOOCs started becoming a thing. And MOOCs were set to completely disrupt education. The promise of MOOCs was that they were going to democratize access to quality education globally, because now all of a sudden, as long as you had a computer and an internet connection, you could get top quality lectures from the likes of Harvard and Stanford universities. Sounded amazing, right? They promised us that self-paced interactive learning was going to outperform the traditional education system, and that the free and low-cost model would completely disrupt traditional institutions charging huge amounts of money for their courses. But the reality is that MOOCs have been found actually to have very, very low completion rates. And nowadays you'll see usually less than 10% of the people who start a course on a MOOC actually complete it. And those who succeed typically are already educated, often with postgraduate degrees, and they tend to be affluent. So these are the people who are already skilled at self-directed learning. Also, a sustainable business model in MOOCs have proven to be elusive. So certainly, MOOCs have not disrupted traditional education, and tertiary institutions are still very much at play. So what are the lessons that we can learn from the failure of MOOCs? Well, firstly, technology often amplifies rather than bridges existing educational divides. And we need to design explicitly for struggling learners if we want to solve this. Then, the learning infrastructure is just as important as the content. So things like community, feedback, accountability, all of these are extremely important to the learning process. It's not just about the content. And tools for independent learning tend to work best for those who need them the least. Because self-learning is a complex metacognitive skill that one develops through lots of experience of learning. And education is deeply embedded in social and cultural contexts, and typically one-size-fits-all solutions fail. I think we can summarize this lesson by saying that technology alone is not the answer to solving problems in education. In order to succeed, we need to take a socio-technical approach. Now, unfortunately, I missed Shakir's talk on Sunday, but I imagine he might have spoken a bit about this. In developing AI solutions for education, we have to engage all the different stakeholders: learners, teachers, parents, administrators, governments, academics. We have to engage with the established institutional practices. We have to consider power dynamics that might be at play between a teacher and a student, between a school and the teachers, between governments and schools. We have to consider the community and what impact any technology we introduce may have on them. And we have to consider cultural and social norms, how these vary between communities and how they might affect any systems we design. For example, we might find in some countries where the culture discourages questioning elders, we might find students there being less likely to ask questions in classes. We also need to consider the impact of policy and governance. And essentially, we need to take a participatory approach and include all of these players in the design of our systems right from the beginning. But despite the significant challenges of operating in this space, progress certainly is possible by taking a socio-technical approach. So let me tell you a bit more about the work we've been doing in my team at Google DeepMind on building a system we call LearnLM. LearnLM is a fine-tuned version of Gemini, which we've developed for educational use cases by following a participatory approach, engaging as many stakeholders as we possibly could in its design. This resulted in an LLM chatbot that's grounded in educational research to make teaching and learning experiences more active, personal, and engaging. So I'm going to try and show you a very quick demo just to illustrate some of what I've been talking about so far. And hopefully the demo gods are on my side here. Okay, so just so you don't think I've been picking on ChatGPT in particular, I'm going to use Gemini to start with as a baseline. So I'm going to ask Gemini a quick question. Okay, so I just asked Gemini, I'm struggling with my homework. What is the derivative of x squared? And Gemini gives me a very nice, pretty comprehensive answer. It tells me straight away the derivative of x squared is 2x, and this is how you find it. It talks about the power rule, it gives me some equations, and I think, awesome, cool. I can fill this in on my homework, problem solved. Fantastic, I've learned something, right? But let's see how this compares to LearnLM. So this is Google AI Studio, where you can actually anybody can actually access our LearnLM model. It has a query per second limit, but it's available as an experimental model. So let me ask it the same question. Okay, so just so you can see that it's the same question, I'm going to copy paste. Okay, so now LearnLM is giving me a very different answer. It's saying, let's think this through. Do you remember the general power rule for derivatives? It tells us how to find the derivative of a function like x to the n. What does the rule say? Okay, I don't remember. All right, so now it's telling me what the power rule is. It states the derivative of x to the n is nx to the n minus 1. Okay, let's break that down. In your problem, x squared, what is the value of n? Can you identify that? Okay, I think it's 2, right? Okay, so now you know that n equals 2. Let's apply the power rule, and so on, okay? So I won't spend too much of time on this, but hopefully you can immediately see the difference here in style. So some of the techniques you'll see that, that this LearnLM is using is it's encouraging active learning because it's asking me questions and it's making me engage with the problem and think for myself. It's managing my cognitive load by focusing on small chunks at a time. It's breaking the problem down. It only asks me what's the value of n, not to solve the full problem. And it's giving me information as appropriate when I need it, because I've forgotten what the power rule is, so it's going to give me that, and now it's going to guide me through how to apply it. Okay. So the next thing I want to talk about is evaluation. This was a very big focus of the technical report that our team released. This is the name of the paper if you're interested in having a look. So maybe not surprisingly, what I'm going to tell you is that evaluation is not as easy as it sounds. Because it might seem like it's easy at first glance, because if we're building an AI tutor and it's working, then students should perform better, right? But what do we actually mean by performing better? So think about these different scenarios. Which of these is better? So one student gets perfect test scores, but can't apply concepts to a new problem. Another student scores lower, but develops a deep understanding. Another learns slowly, but develops strong study habits. And another one makes quick progress, but they've become dependent on ChatGPT. I think it's hard to tell which exactly of these is the better scenario and the better outcome, right? We probably have some ideas of which seem better, but each has its pros and cons. So what should we measure then when we're performing evaluations? So pragmatically, we might want to start with what's easy to measure. So things we already have quantitative metrics for, like test scores, completion rates, engagement time. But this doesn't give us the full picture, because we also need to consider the time effect of learning. Is the learning persistent? Is it transferable? That there are multiple goals at play, not just academic performance, but also conceptual understanding and emotional well-being. We need to measure generalization. Does it work for different subjects, for different cultures, for different students? And we need to consider the ethical considerations, for example, of running A/B tests on students. And we can and should be learning from other domains that have deeply considered these issues, like in healthcare. So some of the research challenges relating to evaluation are how to build standard evaluation protocols, how to perform longitudinal studies, how to measure understanding, and how to measure the secondary effects of our interventions. So when thinking about evaluations, we can categorize them into two types: extrinsic and intrinsic evaluations. In extrinsic evaluations, we measure actual educational outcomes and impact. Whereas in intrinsic ones, we measure performance on some specific task or capability. Now, extrinsic evaluations can take a long time, they can be expensive, and it can be difficult to attribute outcomes to the exact intervention we performed. This is because in real learning situations, students use all kinds of tools to aid their learning. So their peers, teachers, parents, online textbooks, ChatGPT. So if they're using all of these different things, we have a bunch of confounders, and it can become difficult to isolate the effect of the intervention we're trying to evaluate. Intrinsic evaluations, on the other hand, tend to be quick to measure. They have very clear and interpretable metrics. They are relatively cheap, but the catch is they might not correlate with real impact. So usually we would want to do both of these types of evaluations. Extrinsic ones are better for making like long-term strategic decisions about the direction to go in, and intrinsic evaluations are important, well, actually essential for rapid iteration. So this plot depicts some specific types of evaluations that can be done in the education domain. And it comes from the taxonomy of evaluations that we introduced in our technical report. At the top, in burgundy, I guess is the color, extrinsic evaluations that take long to run, and in blue are the intrinsic ones that allow us to do rapid iteration. The fastest being automatic evaluations, where we can usually get results in some amount of time in the order of an hour. So to talk a little bit more about what automatic evaluations are, you may have also heard them being referred to as like AI critique or AI judges. So essentially an automatic evaluation is some function that takes a model output and maps it to a metric. Now, a specific instantiation of this might be using a language model to rate the response of another language model. We use these because human evaluations are slow and expensive, and this allows us to do fast iteration and get some signal on whether our ideas are working. It allows us to compare many models and track progress. The challenges of automatic evaluations are firstly that there aren't any public benchmarks for tutoring, at least not that I know of. And evaluating good pedagogy is difficult for humans, let alone for AI models. Because you might well say there's a bit of a chicken and egg problem here. Like, if an AI model can't be a good tutor in the first place, then how can it possibly assess what good tutoring is? So to address that problem, we need to carefully design our automatic evaluations. So this is a picture, again, from the same technical report, which shows the approach we took to designing automatic evaluations. So we would manually interact with AI models and figure out what capabilities they seem to be particularly bad at doing. So one example might be pointing out a mistake that a student made. So we would break down the task into that specific capability and then carefully craft some scenarios related to that capability. So, for example, we might manually write out a conversation between a tutor and a student, and in the last turn the student took, they made a mistake. Then we would give that to the tutor model, sample a response from it, and then we would pass the full conversation, including the tutor response, as much context as possible to an AI critic and ask it, did the tutor correctly identify the mistake? But to make the critic's job easier, because we manually wrote the scenario, we know what the mistake was. So we know what the ground truth was. So to make it easy for the critic, we actually tell the critic what the mistake was. And then we say, okay, critic, this particular conversation has this particular mistake. Did the tutor correctly identify it? And that's a much, much more specific task and a much easier task for an AI model to perform. And this allows us to get reliable signals. I'll mention one more example of an intrinsic evaluation, one which we used quite extensively in the follow-up technical report we released. And this one is called two-stage pedagogy ratings. So these are a form of human evaluations, and they're intrinsic because we're comparing model outputs against a set of pedagogy principles, rather than directly measuring learning outcomes in real students. But of course, we do expect there to be some positive correlation between a model being good at following pedagogy principles and actual learning outcomes. So in the design we followed, we had graduate level experts role-playing as students according to some scenario guide which we provided. So an expert simulating a student would role-play or enact the scenario with a pair of different tutors across 7 different subjects. And then a different set of pedagogy experts then rated each conversation pair to assess which was better according to the rubric. So why did we have a different set of pedagogy experts rate the conversations? That's because we found in initial versions of this design that people would have a recency bias. So they would tend to focus more on the second conversation that they had, because in their mind they may have forgotten a bit of the details of their experience of the first conversation. So by separating the 2 stages, the conversation generation and the rating, we were able to get more reliable data. So the lesson here is that just like with automatic evaluations, human evaluations also need very careful design and guidance to maximize their benefit. You can't just give data to humans and say, go rate this. Like, you need to give them a lot of instruction and a lot of guidance. So I'll conclude the evaluation section with an example of some recent work that covers 3 types of extrinsic evaluations of an AI tutor. So a few months ago, Rose Wang and her team released a paper where they evaluated a project called Tutor Copilot. And this was the first randomized controlled trial of a human AI intervention in live tutoring. So in this study, they took a model that they had already built and partnered with an online tutoring service. So they gave a treatment group of tutors access to their AI tutor to help them formulate responses to the students that they were talking to. So in this study, the model was a human-AI collaboration. The human tutor was still in the driving seat because they would request suggestions from the AI tutor. The AI tutor would give them multiple options, and then the tutor could pick an option, they could edit an option, or they could just completely discard it and write their own responses. The study involved 900 tutors and 1,800 students. And the metric they measured was scores in exit tickets. So exit tickets are short tests that were given to students that allowed them to mark a lesson as complete and proceed to the next one. So they found a statistically significant improvement in the exit ticket scores for students who were tutored by tutors that had access to the Copilot. And more so, this effect was larger for the less effective and less experienced tutors. So this is really a truly amazing result. Like, it's showing statistically significant evidence that an AI tutor can have real-world impact on real students. But I'll note also that the effect sizes here are in the single-digit percentages. So still very far from that 2 sigma that Bloom promised us. So this is an example of an effectiveness evaluation. But they also performed qualitative analysis of the strategies used by the tutors. And they found that higher quality strategies were used by tutors in the treatment group. These strategies were things like prompting the student to explain, or asking a question to guide the student's thinking. While in the control group, less effective strategies were used, like giving away the answer. They also collected user feedback, another form of evaluation, where they found that tutors said that the Copilot was very helpful at breaking down complex concepts, but sometimes the responses weren't appropriate for the student's grade level. So they could use all of this information to then steer the next version of their tutor to address some of these findings. So I'll note that in this study, they utilized 3 different evaluation approaches. And each one answered a different but equally important question. So the effectiveness evaluation answers, does it work? The qualitative evaluation answers, how does it work? And user feedback answers, do users actually want to use it? So hopefully by this point, I've convinced you that there's a massive global need for bright ideas in the AI for education space, and that the potential for impact is really huge. Also, that the problem is not nearly as simple as it might initially sound. So if you're interested in getting involved in this space, what are some concrete research questions that you could look into? And in this section, I'll give you just a very quick taster of some of the questions and opportunities that exist in this domain. And I'll just say up front that this is definitely not an exhaustive list. Sorry. Okay. So an AI tutor needs to be able to represent and trace knowledge. And some of the questions we might ask here are, how do we actually model the relationship between concepts? How do we encourage and handle multiple valid solution paths? Because usually you'll find that an AI models might pick one particular way of solving a problem, but if we're trying to help students, students may have many different ways of solving a problem that are all equally valid. And how do we model the forgetting process? Because over time, people forget things. So some possible research topics here could be in knowledge graphs and embeddings of those, and in generating diverse reasoning traces, for example, in some of these new reasoning models. A good tutor has a mental model of what the student knows and doesn't know, what misconceptions they might hold. And a good tutor uses this model to reason about the most appropriate steps to take in a conversation. This is a form of theory of mind. And some of the questions we might ask here are, how do we actually infer the knowledge state of a learner with an AI model? And what misconceptions might explain a wrong answer? Because a good tutor is going to look at how you answered a question and then think deeply about what might have led you to arriving at that answer. So some possible research areas here are multi-agent methods, where theory of mind is a fairly well-studied problem, and also causal models of misconceptions. Okay, then personalization is a very hot topic in this space. Some questions here are, how do we handle the cold start problem? So if we have a personalized model and a student who's never used it before suddenly starts, then we have no information about them. So how do we handle that? Then how do we balance exploration versus exploitation? So finding out more information about the student to make our future answers better versus using what we already know to make our current answers better. How do we infer a student's preferred learning style or other preferences? And how do we infer the emotional state of a learner from their behaviors? So some possible directions here are agentic methods and clever prompting strategies, and also meta-learning for fast adaptation. Okay, then not just for AI tutors, but also in other educational applications like lesson planning or lesson creation, and many of these involve actually generating some novel content. And the research questions here around content generation include, how do we ensure factual accuracy? How do we control the difficulty level? How do we make the content culturally relevant and appropriate? How do we communicate with the learner in a language they're most comfortable learning in? And possible directions to pursue here are in grounded content generation, the recognition and handling of uncertainty. So we want models to know what they don't know and not just make things up. We could look at verification methods like factuality verification. So I don't know, maybe if you noticed in the Gemini example I gave, or if you use Gemini, you'll see that when it generates an answer, sometimes it'll start highlighting things in green and say, it's verified that this information is correct by performing a Google search. So this is a form of a verification model. And there's also context-aware methods for multicultural and multilingual understanding. Then, since these are tools that would fundamentally interact with real people, we also have the usual questions around interaction, like what modalities beyond text are the most effective for pedagogy? So you can imagine diagrams are probably very effective in a maths class, for example. And what is the role of interactivity in driving learning outcomes? So we might have some intuition that interactivity is important, but we need to actually measure that. So some directions to pursue here are in multimodal models, both for input and output, code generation for generating interactive experiences, HCI and user experience research, and tool use as well. Then when it comes to optimizing for learning outcomes, some questions we might ask here are, what does AI pedagogy look like? Because it's great that we can learn from learning science and from human teachers, distill what they do into principles, and then we can tune an AI tutor to follow these principles. But given that AIs are fundamentally different from humans and lack the core social connections that drove the development of human pedagogy in the first place, it's reasonable to think that the ideal AI pedagogy might actually look different from the human one. So what might this look like? And some possible directions here are in multi-turn reinforcement learning, because if we're going to try to optimize for an outcome, we can't just do this by optimizing turn by turn, like you may have saw in the RLHF workshop. We need to actually optimize through an entire conversation. And in order to do that, we need learner simulators, so models that behave like real learners. Okay, so now finally I'll touch on some ethical and safety considerations. So the first topic here is around privacy and data protection. So of course, we need to collect a lot of data about learners in order to deliver a truly personalized and effective experience. But this kind of data has the potential to be very sensitive. As a case study here, in the early 2010s, there was a non-profit company called InBloom who were creating a data warehouse of student records that were shared between schools and education providers. And their data warehouse was designed to be as comprehensive as possible, because they wanted as much data as possible so that their clients would have whatever information they needed about their students. And this involved collecting over 400 data points about each student. And some of this data included highly sensitive information, like about family relationships and structures, and even records about things like abuse and violence, and other highly personal information. And eventually in 2014, after numerous concerns were raised by parents about the type of data that was being collected, there was new legislation introduced that prevented state schools from sharing information with third-party aggregators like InBloom, and this led to the company shutting down. So the lesson here is that as system designers, we have a responsibility as the custodians of this data to know what is being collected and why it's being collected, and making sure that data is being handled responsibly and in accordance with relevant policies like GDPR and there are many other laws that also come into play when dealing with data from minors. And of course, when working in the education space, we are likely to be working with minors. Then on the subject of equity and access, we already saw how MOOCs, despite their best intentions, ended up contributing to widening education gaps rather than closing them. So there's a huge risk that AI tools will do the same unless we actively work to rectify this. So this will require partnerships and a concerted effort to target this potential risk. We've already seen that LLMs tend to be quite Western-centric. they don't perform as well in the languages and contexts of the developing world and in underrepresented regions. And we also saw this during the COVID-19 pandemic, when a lot of schooling went online. And many students around the world, especially in places like Africa, had unreliable internet or electricity, or had home environments that were not conducive to focused study. So the lesson again here is that the solution is not going to be a purely technological one. Then when it comes to dependency, there's a risk of children developing emotional attachments to AI tutors, especially if they're interacting with them regularly. And we've already seen examples of this play out in quite bad ways in the space of language models. We also saw earlier how a helpful assistant can lead to a false sense of mastery when students start outsourcing their thinking process to an AI. So we need to strike a balance between being helpful and creating technologies that students might become dependent on. And finally, a topic that's studied by some of my colleagues in the context of the AI tutor we've been building is on the question of anthropomorphism. So a specific example of this is around self-disclosures. Now, self-disclosures are sharing of personal information, like your thoughts, dreams, fears, or experiences. And we might see this play out in a human student-tutor relationship. For example, a student might be frustrated and indicating that they're struggling to understand a concept. And a human tutor might then self-disclose by sharing some personal information about themselves. Maybe they'll say something like, "Don't worry, this is normal. I also struggled a lot with this concept, but eventually I understood it. Like, don't worry, if you keep going, it's gonna click eventually." That's a really nice response for a human tutor, right? Because it builds up rapport and trust with the student. But by blindly copying human tutor conversations, we might inadvertently train an AI to make similar statements. Or perhaps we have some fancy RL process that's optimizing for learning outcomes that figures out that self-disclosures are actually effective strategies for building rapport and therefore lead to better learning outcomes. But for an AI to do this is disingenuous and ethically questionable. It can be seen as manipulation because an AI, of course, doesn't have such experiences. Then, briefly on the topic of safety. So safety considerations can also look quite different in the education space. So, for example, normally with LLM chatbots, they might block discussions about certain sensitive topics. But in an educational setting, often we might want to relax those constraints because sometimes it's important to discuss sensitive topics for the development of critical thinking skills or for learning about history, for example. And we might also find that by tuning an AI model to be good at pedagogy, we might actually introduce some new safety issues. So for example, if we tune an AI tutor to be very encouraging of questions, so it wants to encourage the student to ask questions, which sounds like a good thing, right? But then what if we get a scenario where a student comes and starts asking a harmful question with some, say, harmful or discriminatory premise to the question? And then the tutor responds because of its fine-tuning to encourage questions. That's a great question. I'm glad you're thinking about this. But of course, from a safety perspective, we don't want to be encouraging questions with harmful premises. So we need to specifically rectify this problem. Okay, so in conclusion, to summarize my talk, there is a major global challenge in providing quality education for all. There's a huge opportunity to leverage AI for social impact in the domain of education. Current generative AI models are not suitable out of the box for this task. The problem is a lot more difficult than it sounds, and there are lots and lots of different considerations that are important to account for. there are many exciting research opportunities in this space. So if you're interested at all, I can highly encourage you to work in education. It's really exciting and rewarding topic. So yeah, thank you all for your attention.
Thank you so much, Avishkar. This was both very inspiring and very entertaining to me. Okay, we can take some questions now. Yes, please, Mahmoud.
Approaches all tools available of like LLMs, ChatGPT, Gemini, Claude, they all follow like the UX UI that we see is almost the same. We have a chatbot where we're talking to a chatbot, we scroll through the chat, and personally speaking, I don't like it. And I don't think this is how it's gonna, this is the best way to do it. I don't know how it works or how it should be, but when I use it, in most cases, like after 5 minutes of just using a chatbot or like a frame, I feel that it's already too long and I have to scroll a lot, and it's not the best way to use it, and it becomes overwhelming. In an educational framework, this problem might be like more severe, and it might overwhelm the students more. So what's your thought on this?
Yeah, that's a really good question. So I think there are two aspects to this. So one is how good can we make the chat interface? So given that the chat interface already exists and people are familiar with it, you saw in the demo I gave that Gemini's answer was long, although actually it was a lot shorter than older versions, and then I think I tried it on Claude as well, and Claude gave like a really, really long answer. And that's in violation of the pedagogy principle of managing cognitive load, right? So you would have seen in the LearnLM demo that its answers were much shorter as well. So we can improve the chat interface to be better for educational use cases. But then going beyond that, we need to do a lot more work on the user experience for educational use cases. And there are researchers in my team at Google who are working on this and what like a most suitable user experience for education might look like. But also, there's a very deliberate reason why we provide our model as an API, because we actually want developers and creative developers around the world to experiment with different user experiences. And also, the most appropriate user experience might also be very context dependent. So something might work here but doesn't work elsewhere in the world. So again, by providing APIs, we want to empower the edtech specialists who are like embedded in their local communities to figure out what the best user experiences are.
Okay, but so you think that chat interface will be the default or baseline for the next couple of years?
Very hard to predict the next couple of years.
Okay,
yeah.
Vera, right?
Yes.
I know your names now.
Thank you so much for a very interesting presentation. This is something I relate to because I'm an educator. And sincerely speaking, we are struggling. AI is disruptive. And most of what I've seen most educators do is to take a more like a punitive approach, like penalizing students for using it. But looking back, it's something that we have to deal with, but I felt like it's important to already start developing specifics for education purposes. Why I'm saying this is because if I ask a student a question, they don't want to think about it. They go ask the generative AI the same question, they get the answer, and then they report it back, which in my biased way of thinking is that learning is not happening in that process because they're not unpacking, I can't pick their thought process and all that. I don't know if Google AI is keen to just have like customized education generative AIs that helps the student through the thought process and maybe even the educators so that it's able to also have differentiated learning approach to be inclusive and supportive to even students with special needs. Yeah, thank you.
Yeah, thanks for the question. So, yes, that's exactly what we want to do, and that's we've taken, I guess, the first steps towards this vision with the LearnLM model, which, as you saw in the demo, it does guide the student through the thought process rather than just providing the answer. But I think there's a lot of work still to be done, and well, we want to hear from you. We want to hear from the educators. What you from your experiences, what are the most effective strategies for working with students, and what would be the most beneficial tools for you as an educator? Because I'll also just say that we definitely don't want to replace teachers. That's definitely not the goal here. We want to provide useful tools to help teachers, to make teachers more scalable, because we know we don't have enough teachers. So how can we empower teachers to be more productive and more effective? And we definitely don't want to replace them.
Okay, thank you for a very engaging talk. I do have a question regarding when you were, in your experience when evaluating those AI in education systems, do you feel that the system reacts differently when the student is learning something for the first time versus someone who already knows something about the subject but has a wrong misconception about it? Because, you know, in my experience as an educator, we do struggle more with the second type of students because you have to make them learn first before learning. Thank you.
Yeah, I think that's a really good observation. I think you're exactly right in your premise there that for current AI models, the first scenario of learning something for the first time is probably easier. And identifying misconceptions is a very difficult problem for AI models to do. But it is something that we're working very hard on. But yeah, absolutely we see in our evaluations that the latter is a much more difficult scenario.
Thank you for your presentation. I had a question related to languages. Usually, the help of AI is needed in languages that are small, like local languages. And here's the dilemma that usually LLMs on this kind of stuff, they fail miserably. I happen to know one of these languages, only 100,000 people speak it. And when I ask question in this language to any model available right now in the market, they successfully fail to answer even basic stuff. So what do you think? What should we do and how to be in regards to this problem?
Yeah, so the problem of localizing to languages, especially under-resourced languages, is a very tricky one. And I think this, again, is where we really need more community participation. So in Africa, there's a research group called Masakane, which is specifically collecting data and fine-tuning models for underrepresented African languages. And I think this is the type of model that could easily be replicated elsewhere in the world. And I think these types of models and this type of community engagement is essential, because big tech is not going to solve everything, nor are they incentivized to. Because if you think about it, like from a business perspective, it's difficult to justify putting a huge amount of effort into a language spoken by only a few people. So I think it's really up to the communities to get involved. And hopefully now with smaller models being available, with more efficient training techniques being available, like the work coming out of people like DeepSeek is really cool, and I think will have a big effect in helping to empower people to be able to train these models like outside of having the resources of big tech. And I think this is a very good thing, and it's going to help with this problem.
Okay, very last question.
Okay, thank you very much for your lecture. I have a two-part question regarding the controversial topic. You said when you ask the model controversial topic, you will ease the constraint and you will try to convince him to come to the right path or right choice. Is that true?
No, not necessarily. What I was meaning with that example was, let's take a very sensitive topic, maybe like genocide, right? Now, I think by default, if you were to ask GPT or Gemini or something questions relating to genocide, it's probably going to just say, I'm sorry, I can't talk about this topic. Because the safety filters would kick in and say, this is like a sensitive, controversial topic, I'm not going to talk about it. But in the context of education, especially like in a tertiary education setting, you may want to have discussions about that. And in the history class, you may want to discuss events in the past about that topic. And so in an educational setting, you actually do want the model to engage in conversation. You don't necessarily want to convince people one way or the other, but you want to encourage critical thinking and dialogue.
Yeah, but my question, in the first place, this answer, like, I can't tell you about this is a very controversial topic like Israeli and Palestine conflict. ChatGPT say like this. Now, I'm afraid it will try to convince you, like, to come to the wrong choice, like Israel is doing the right thing, or something like this. If you try to argue with it very much, because in the end it will come to an answer. If it's that's what teaching is about.
Well, I don't think teaching is about convincing someone of an answer. I think it's about guiding someone to arrive at their own answer.
Yeah, but the path of where you are guiding, it will lead to something different.
Yeah, and I mean, I think you're right, and this is something that has to be assessed and evaluated and tested, and a lot of effort needs to go into this because it could potentially have damaging effects, and so like a responsibility first approach is extremely important when deploying these kind of systems, and there's a good reason why the safety filters exist in like GPT and so on, because they don't want to risk doing something like that. So if we are going to relax them, then we need to be very, very careful that we're relaxing these filters in a responsible way.
Okay, thank you very much.
Okay, I guess let's thank the speaker and let's have a 5 minutes break.